Alrighty, class. This is the continuation of the review for 8.1 through 8.6. This is the second page on the document that you have. And now we're adding and subtracting. This tends to be slightly harder than multiplying and dividing and also and simplifying, reducing. All right, to add fractions, remember the bottoms have got to be the same. We have to find a common denominator. So when you see on this problem here, 4a, you have an 8 in that denominator and a 5x minus 2 in that. So the LCD will be 8, and then whatever's on this fraction, which is 5x minus 2. That's the LCD. And what I'm going to do with that LCD is that I'm basically going to take this fraction bottom, 8, and turn it into 8 times 5x minus 2. In other words, I'm going to turn this into that. And when I do that, I multiply top and bottom by what's missing. And what's missing is the 5x minus 2. So that's where this term came from. I basically, for these simple ones, it's just that. I'm going to take 7x times 5x minus 2, and then minus 8 times 8x minus 4. Notice this minus came from the fact that that was subtraction. So now this turns into this problem. And now it's just a process of simplifying. So 7x times 5x gave me the 35x squared. 7x times a negative 2 is negative 14x. 8 times 8x is 64x. And 8 times negative 4 is negative 32. And the bottom comes along. This is just simplifying. Be careful of that negative sign. That means we're subtracting all of this, which means you flip the signs in the back and make that plus. So you got 35x by itself, and there it is. Then you got negative 14x minus 64x. That's going to be negative 78x, which is that. And then this is where it's a little bit tricky. Negative, the opposite of negative 32 is plus 32. So we ended up with this as your answer. Note the LCD just kept coming along for the right because there was nothing we can do with it. Now, theoretically, you should try to factor the top. See if that's a quadratic. Maybe it can be factored into something simple. I don't think so because it looks kind of ugly. You got 35 in front, 32 in back. It's a little bit ugly. But you should always think about that. All right, the next one. You really just have to cross multiply. So 4 times x minus 2 right here. And then x plus 7 times 7 with this negative sign that was right there that comes along. So this is what we have on top. On bottom, we just have the product of those two. So this now becomes this. Now it's a little bit scary. It's a little bit ugly. You know, you're going to have to distribute the 4 and distribute the negative 7, not the 7, but the negative 7. So 4x times a negative 2 is negative 4x minus 8. That's this term. And then negative 7 times x is negative 7x. Negative 7 times positive 7 is negative 49. And those are these two. Combining like terms. 4x minus 7x is negative 3x. And then we have negative 8 plus a negative 49 is a negative 57. Notice the denominator comes along for the ride. Okay? And so the last thing I did is I saw I could pull a negative 3 out of these two, and we get this. And this is the simplification of that rational expression where we're subtracting. All right, so you saw an example of adding. We saw an example of subtracting. Subtracting is harder mainly because you have to remember you're subtracting all of this second piece. So you got to remember that this is a minus in between, which is shown up right there, which you have to remember that when you distribute, this is a negative 7 multiplying in to give us these terms. As long as you pay attention to that, it shouldn't be an issue. Likewise, now multiplication tends to be easier. All right. But the thing is, there's an F word that you have to use all the time with this. You have to factor. The first thing you should do when you see a polynomial like this is to factor it. What multiplies, just as a refresher, what multiplies to 25 adds up to negative 10, and you'll see it's negative 5 and negative 5. We call this a perfect square trinomial. So we can rewrite this as x minus 5, x minus 5. On bottom, this 10x minus 100, you can factor out a 10, GCF it. And you can pull a 10 out. And that leaves you with x minus 10. Okay, I'm going to go ahead and scooch down this expression right there. Oh, that's going to move everything. Scooch down this so I have more space. And now we look at the second fraction. Okay, we have an x minus 10. We can't factor this, right? That just sticks. And we can GCF out a number here. That's 45 minus 9x. A common 9 can be pulled out. And that's what happens here, right? So now we have this. And right away, you should be able to see that the x minus 10s divide out. Remember when you kill the x minus 10 on top, there's a 1. Don't leave it as a 0. It's a 1. Okay. Now, we have this 10 that nothing attaches. There's nothing common top and bottom. We have this 9, so we're going to end up multiplying them together. 10 times 9 is 90. So on the bottom of this fraction of this sum is going to be a 90 right on the bottom. I don't have enough space for the top. Okay. And then I wanted to point something out. You have two things right here, this x minus 5 and 5 minus x. They're almost exactly the same, but different, right? One's x minus 5, the other one's 5 minus x. It's kind of like 3 minus 1 is 2, 1 minus 3 is negative 2. And so when you switch the order of subtraction, when they get switched, right? Instead of x being positive and 5 being subtracted, 5's being positive and x is being subtracted. When that happens and you divide them, they don't divide out to 1. They divide out to negative 1. So that's a warning. That does divide out, but that introduces a negative 1. So now we already figured out that 10 times 9 is 90. We have left one of the x minus 5s. So that's still here. We don't have an x minus 10 because that's gone. And we just have 90 on bottom. So it looks like this turns out to be this right here. All right. And that's how you do these two. It's not real. This is still not too bad. It's just a little bit painful. All right, so now on this one, like I said, the F word comes into play. You have to factor. So what I did on top here is I looked for two numbers that multiply to negative 36, add up to negative 5, and I saw that that was negative 9, so it's x minus 9 and positive 4, so that's x plus 4. All right, the bottom here, it's a binomial. And so doing an x factor doesn't really work, but you should see that, hey, wait, that's cubed and that's squared. I can pull it, they have a common x squared here. There's a 3 and a 12, so the 3 can come out. So it's 3x squared times x plus 4. Then when you look, you see that the x minus 9s divide out, the x plus 4s divide out. You're left with 45 x squared. And by the way, what I wrote here was wrong. It's 45, because I wrote 4. It's 45 x squared over 3x squared. Now, 45 divided by 3 happens to be 15. And this turns out to be just the number 15. All right? And that is an example of 5. On 6, you still have to factor, because we're going to turn this division problem, this right here, into a multiplication problem by multiplying by the reciprocal of 1 over x minus 5. So my first thing is you should factor this trinomial. So that's going to be -4 and +2. Okay. Notice that x minus 4 and this x minus 4 divides out. Now it's just 1 over x plus 2 divided by 1 over x minus 5. Now, to turn division into multiplication, we flip right, multiply. So, I'm sorry, just lost my thought for a second. All right, so this is still division. So to turn division into multiplication, when we're dividing by a fraction, we multiply by the reciprocal. So 1 over x minus 5 turns into x minus 5 over 1, and now this is multiplication. Now, you multiply straight across, and top and bottom, and you end up with 1 times x minus 5, which is x minus 5 on top, and 1 times x plus 2, which is x plus 2 on bottom. And there you go, and that's fully simplified. All right? Okay, moving on, .org. Okay, so here's 7. Now we're doing solving equations. All right, 7 is simple proportions, which basically mean you cross multiply to solve. It's the easiest way of thinking of it. And then 8 is uglier equations. So here we go. Cross multiply to get rid of I just lost my train of thought, sorry. So what we're going to do is go 5 times x plus 5. So we get this. Then we're going to go 8 times x minus 9, which is this. Again, I went like that. Okay. Now it's just a process of distributing the 5 and the 8. So 5 times x is 5x. 5 times 5 is 25. That's this. And 8 times x is 8x. 8 times -9 is -72. Now this is a linear equation with variables on both sides, so we got to hook up the x's. So what I did was I subtracted 5x, That left us with 3x on back, and then what I also did was I added 72, and 25 plus 72 is 97. So we have this. Last step, divide by 3, and the solution would be this, 97 thirds. Okay. 3 does not go into 97, so that's all you can do. And that was number 7. A. Number 7b, you cross multiply again. So 4 times 6 is 24. That's this. And then 9 times x minus 3 is 9 times x minus 3. 4 times 6 is 24. Distribute the 9 in. 9 times x is 9x. 9 times -3 is -27. Hook up the numerical answers. So 24 plus 27 is 51. So we have that. Divide by 9, and we get oh my gosh, I'm still recording. I stopped. I'm so terribly sorry. All right, the ugly one. Now we have a quadratic on bottom right here. Okay, so we have to factor that, which is x minus 5, x minus 2. Once we factor this, we then look at each denominator and write down the factors we see. We see an x minus 2, we write x minus 2. Here with this in factor form, we see an x minus 5, we write it. And then we already see the x minus 2 from here, so we don't write it again. And then here's another x minus 2. So the LCD is just this, the factorization of that. X minus 5 times x minus 2. All right, so what we're going to do is multiply 1 over x minus 2 by the LCD, by this x minus 5, x minus 2. Okay, you're going to multiply each fraction involved in this. And if it's not a fraction, you still multiply it. All right, so the next one, notice I'm going to write this one in factor form. Oh, sorry, that's not factor form. Okay. And again, I'm going to multiply by the LCD. LCD, got to multiply by it. So there we go. Okay. And then this is going to equal the 6 over x minus 2. Now again, we're going to multiply by the LCD. And then we look, because all the denominators should go bye-bye now. So the x minus 2 divides with that x minus 2. This x minus 5 kills that, but so does the x minus 2. So notice that the LCD is exactly the denominator of that fraction. That right there is just the product of the LCD. And then over here, the x minus 2 looks like divides out. And there should be a black little like that. Okay. So what that leaves us is 1. Now I'm just going to go through the algebra. 1 times x minus 5. It's just x minus 5. Okay. Plus, now everything divided out, there's a 1 here. So this is going to be 1 times 1, which is 1. Oops, sorry. And that's got to equal now, all we have here is 6 times x minus 5. Now we're just going through the process of solving this. That means distributing the 6 on the right. So 6 times x is 6x. 6 times negative 5 is negative 30. Combining like terms, negative 5 plus 1, and that's x minus 4. Hooking up the x's, subtracting x, and adding 4, or actually, excuse me, adding 30, because that I want to get the x's by themselves, and I won't if I add 4. So I'm going to add 30 to both sides. So now x and negative x go bye-bye. You got negative 4 plus 30, which is 26. Here, 6x minus x is 5x, and the 30s go away. Dividing by 5, you get x equals 26 over 5. Kind of ugly. When we solve these equations, always check that it doesn't make the LCD equal to 0. And 26 over 5 does not make the LCD equal to 0. Okay. The last one is probably the most complicated. All right? First thing is the F word. Factor everything that could be factored. And also, I just saw this. I didn't do it the first time I did this, but I just saw this. This denominator is the same as that. So I could just add this to this side, and this turns into, well, if I do that, I won't be able to, oh, I don't know. I'm going to go ahead and do it. So I'm just going to add this fraction over to the other side, which is going to mean I add it to here. Okay, so now it becomes 3x squared plus 21x. Now we have the 1 plus the 18 is 19. Okay, all over x squared plus 2x. And this has got to equal 1 over x. Okay. So now what do? We could cross multiply. So we got x times, and again, this is ugly. This is not fun. 3x squared plus, 3x cubed, because we're multiplying by x. So that's 3x cubed, 21x squared plus 19x. And then on bottom, or not on bottom, and that equals this product right there, which is just x squared plus 2x. All right. So distributing the x on the left, that's 3x to the fourth plus 21x cubed plus 19x squared equals x squared plus 2x. Subtracting x squared, we get 3x to the fourth plus 21x cubed plus, subtracting 2, 17x squared, plus 18x squared. Okay. So, gotta be careful. All right, let's see. Let's just start over. Okay, so I'm going to distribute in the x. That's where these terms came from. Equals this. So I gotta go slower because I think I was going to screw it up. I'm going to subtract x squared from both sides. I'm also going to subtract 2x from both sides, and there's no x over here on the left, so that just means it's going to be minus 2x. So we have this, 3x to the fourth plus 21x cubed plus 18x squared minus 2x. And the 2x came from this. And that's got to equal 0. Crazy, 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 crazy. Okay. So looking at this, I can't pull out 3, so I can pull out an x. That gives us 3x squared, or x cubed, plus 7x squared plus 6x minus 2. And that's got to equal 0. And all of a sudden, I see that I'm running into a problem because I got this off the internet. And this is a much more involved problem than what you will ever see in advanced algebra. Because now we got to figure out how to factor this. Okay? And that's going to be kind of hard to do right now. So, what I would argue is, don't stress too much. I did it a different way, and I got these two answers. So those are the two answers, okay? And if you look back, x equals -1 does not make the denominators 0. So that's good. That was the one I was concerned about. So that's it. I hope it didn't overwhelm you. If you have a lot of questions, come see me in office hours tomorrow, and good luck.